Okay, these are my comparison for how photons work. As you can see, I have an electric inlet here to a switch, which goes to a bulb, which goes to another switch, which the electricity is always on here, but when I turn this switch on, it feeds electricity through the bulb to this point on this switch, but it's not allowed to flow. There's no pressure there. It's electrified, but electricity works different than water. And I'm going to compare water to electrical current on how photons work in this video. But when I turn this switch on and let the pressure go, the light comes on. So it's coming in and coming up to this switch, but it can't get through. It can't pressurize. It's pressurized up to there, but it can't move anywhere. But when I let it move through, that's when the bulb illuminates. And what I'm going to show here in a little bit is how I can show you how photons work with water, which I have a water hose coming in with a valve here and a valve here. This piece of plastic has holes drilled in it. And when I turn the water on to this valve and leave this valve open, the water is going to flow through and it won't come out here. So in other words, there's no resistance. And like this, with this switch on and this one off, there's no resistance because there's no pressure. The electricity is not forcing the filament to get excited. Right now it's all sitting idle. But as soon as I turn this switch on, it lets it flow through. So this has to conduct that flow, makes pressure. So the pressure, electrical conduction, the voltage, amperage, makes the bulb illuminate inside the vacuum of the bulb itself, which we all know how incandescent bulbs work. But I'm going to show how water can do that without a vacuum, how it does the same thing that photons do. This demonstration is going to show how photons work in electrical current by using water. That is the whole point of this experiment. It's off. Add resistance. It's on. It's off. No resistance. Add resistance and it comes on. That's why photons are made in the filament. No resistance. Electricity is not going anywhere. As soon as the electricity goes somewhere, it causes the filament to conduct, which causes pressure or causes the accelerated gravity, the electric current, to move. And the filament has to move it for what this wire can handle. And the filament is smaller, so it can't handle as much as the wire can. So it gets excited and puts out light. When I shut it off, it's electrified up to here, but not enough resistance or movement or flow to make the filament electrify. Electrical switch with the switch off. I've got it on here, so I'm energized up through. There's no real pressure, no resistance. So there's not photons being made, just a dribble, which means that's just like the filament of the bulb conducting the electricity. It's really not going anywhere, so you don't have a lot of photons. But as soon as I add resistance, it sprouts out, or spruces out, or spouts out. So as soon as I add resistance, you get photons. Take off the resistance, no photons. Add resistance, you get photons. So that's how that works. That's how electricity works if you compare it with water. There's no resistance here, so I'm not getting very many photons. As soon as I add resistance, I get photons.
Okay, here they are side by side. If I add resistance, I get photons. Take away the resistance, I don't. On the electric current, it's just allowing the flow to go through and go to Mother Earth, which pressurizes. The bulb has to conduct, so it's like pressurizing. And when I do the water, I have to reverse it. But when I close the water valve down, it pressurizes it and makes photons.